Um, I'm Bridget Krumhoek. I work for Pivotal. You're probably coming to this because, I don't know, it's on the way to the snacks or you want to know about cloud native or something. But yeah, so we're gonna talk a little bit about cloud native platforms. A little bit about me, why I'm talking to you here today. I actually am not from the Bay Area, I'm from Minneapolis. I work for Pivotal on the tech advocacy team for Cloud Foundry. I co-host a podcast, Arrested DevOps, with Matt Stratton from Chef and Trevor Hess from 10th Magnitude. And I'm part of the shadowy cabal that brings you DevOps Days. We're not actually shadowy or a cabal, and if you want to bring a DevOps Days to somewhere else, other than the Bay Area, which of course already has one at the Computer History Museum in Mountain View that just happened. But if you would like to do a DevOps Days somewhere, let me know, talk to me, it'd be pretty cool. Okay, so let's talk about infrastructure choices. I think these are waters that a lot of us are trying to navigate at this point. And it seems like there is an increasing plethora of choices like every day. So every day you hear that Netflix has open source Spinnaker, and Yelp just open sourced a PaaS, and it's kind of like an Oprah thing, right? Like you get a PaaS and you get a PaaS, and maybe there's one under your chair right now. Who knows? But when you're trying to figure out, like, all right, what kind of platform are you actually going to run your software on? This is one of those things that I think we at Pivotal can kind of give you some guidance with. So I work for Andrew Schaefer, who's kind of a, what does he like to say? Hashtag not all DevOps luminaries. But he's been working in this space for a while, and one of the things that he started talking about a while ago, and I think that we've all started realizing is kind of a thing, is that ad hoc automation is not going to solve all your problems. So, like, you start thinking about more structured platforms once you get past this, like, let's automate all the things meme. It's like, okay, so we automated all the things. Things aren't actually better. So how do we make things better after, automating all the things does not actually work? And this is kind of my pitch against the ad hoc automation, is that just because you can automate something that you were doing some sort of totally kludgy, terrible, janky manual way, does not mean that you probably should. And I think that that's one of those things, like, as engineers, we want to build things. We want to create things, and building things is fun. But that does not necessarily mean that that's the best way for us to add value to our organizations. And I think that's kind of one of those tough things for us to realize, is that that might not be the best solution for us. Talking about platforms a little bit, Simon Wardley, who is an interesting thinker in this space, recently tweeted this image, and it got me to thinking. Like, we spent a lot of time talking about containers and, dockering all the Dockers, because you have to Docker all the Dockers, right? Like, that's a checklist. After you microservice all the microservices. And we spent a bunch of time talking about container orchestration and scheduling, which, by the way, like, I have an HPC background, so scheduling, not actually new. Like, talk to me later about OpenMPI. We've been doing this stuff for a long time, but it's suddenly exciting and quote-unquote new in the cloud space. And I think that when we focus a lot on those individual components in the structure, in the underpinnings of our platform, we forget that the entire point is to be able to operate software. Like, the entire point is to be able to deploy and run our software, hopefully, probably in the cloud. Which, by the way, I mean, let's be honest with each other. Like, we're a small group here. We can not lie to each other. The cloud doesn't actually exist, right? I mean, it's somebody else's computer. It's probably in Virginia and US East 1 or whatever. But, like, when we're operating this, software in the cloud, we want something to operate it on. Probably not just the entire bag of tricks that AWS has to offer, because you kind of stick your hand in that bag and it's full of sharp objects, and there's a lot of learning curve there, especially for people who are moving into the space. So, all right, so we're thinking there has to be a better way to operate our software in the cloud. Like, what is that better way? All right, let's talk about platforms. And, okay, now, funny picture aside, I don't actually mean orbiting space platforms, though that would be cool, except for datetime libraries, right? Because when you start, like, thinking about space travel, suddenly all of those, all the cursing that you've done at the Python datetime library becomes much more dire. Like, I don't even want to think about what, with interplanetary expeditions, what the datetime libraries are going to look like. Probably something really tragic. But think about it, like, you have a platform. And if you're deploying and you're operating code somewhere, you have a platform. I mean, maybe it's like the platform that I helped build when I was at a streaming video startup that was a Drama Fever. You may or may not have heard of it, but it was much like Netflix. If Netflix were much smaller and mostly Korean soap opera, like K-dramas, and ran Docker in production. Because, you know, that's, okay, not exactly like Netflix entirely. But when you're operating a platform of some sort, no matter what it is, even if it's, you know, built out of a whole bunch of Docker and Python and some Chef and probably some Packer, because you gotta use something from HashiCorp, right? And some janky bash, because if people tell you there's no janky bash in there, like they're totally lying. When you're operating something like that, you have a platform, even if you're not calling it an as a service or whatever. There's a lot of talk in this space about opinionated platforms, and you're thinking, I mean, I have a lot of opinions about software. I'm a professional. This is what I do. Why do I want someone else's opinions? It's like, maybe I don't want someone else's opinions. Well, okay, so talking about opinionated platforms, Andrew Schaefer tweeted what I thought was this really great picture, this infographic to help people understand opinionated and unopinionated platforms. So we've got our opinionated tree houses, and we have our unopinionated tree houses. Our unopinionated tree houses are basically 2x4s. When he tweeted this, Kelsey Hightower actually answered on Twitter and said, well, Kubernetes isn't really like 2x4s, it's more like you have 10 different ladders. And I'm like, Kelsey, you're making his point for it. Which is to say that the undifferentiated heavy lifting of platform construction is possibly not where we want to spend all of our innovation tokens. Like if you read there was a great blog post last year called Choose Boring Technology from Dan McKinley, formerly of Etsy. And he kind of made the point that we can innovate so many times. We should spend our energy where we're going to get the best value out for it. So if you're spending your energy on building like an artisanal bespoke platform, you're not spending your own energy on something else that might add more value to your business. So yeah. And while we're talking about buzzwords, because we have to talk about all the buzzwords, right? I mean, I feel like I was just over at QCon, and I think there was a microservices drinking game going on. Like every time somebody says microservices, gotta take a drink. I do a lot of DevOps conferences. I feel like when we talk about, you know, DevOps and microservices and continuous delivery and, you know, cloud native, and we're pretty much talking about all the same things, right? We're talking about trying to build something that we're not just forklifting into the cloud, but actually works in the cloud natively. And when we're thinking about that, like Mark Imbriaco tweeted it, who is formerly of Heroku, GitHub, DigitalOcean. He's now doing a startup called Operable that's, you know, ops as a service stuff, pretty cool. But he's an interesting figure in this space, and he tweeted something, and this was actually back in September 2014, where he was talking about people who think that they're doing DevOps may just be building a PaaS. Like they're building something that they're operating for their developers to hopefully in more or less of a self-service way deploy and operate software. Like, I kind of, when I read this, I thought, yes, this is exactly what I've been doing for years. It's like building platforms again and again and again. And this is, we're all building these similar things. This is actually probably Schaefer, who I work for at Pivotal. Full disclosure, I put lots of Schaefer quotes in my decks even before I worked for him. But you know, I mean, that's what you do, right? It's like you go work for your friends who say cool things on Twitter. But he pointed out that this is probably the most interesting, possibly the most important sentence from the board paper, which is to say that when you're building applications to run in the cloud, it's super important to make sure that those applications are responsible for and reporting on their own health, their own metrics. And the implication being that the application is telling the truth, right? I mean, you've all seen those applications where they're like 200 okay, everything is fine, and you're like, everything is not fine, everything is on fire. So if it's actually reporting accurately and correctly and telling you what the application is, you know, experiencing and whether or not it's healthy, like then your platform can run the application accurately, scale it accurately, you know, remediate problems. But it is super important that your application is actually telling you what it's experiencing. And that's kind of one of those those principles of like, we can't lie to each other. Like developers and operators can't lie to each other if we're going to operate and deploy and operate services accurately. And I kind of feel like we've spent so much time siloed away from each other and not telling each other the actual truth because, I don't know, we figure that the person on the other end of that, you know, the person on the other side of the wall of confusion isn't going to let us do what we want to do or whatever. But like the principles of actually operating openly and honestly with each other, are way more important than like the stuff that we're actually doing, which is way more important than the tools we're using. So like, even though I'm here talking to you from Pivotal, like, you know, supposedly about Pivotal, like, I'm not actually here to sell you anything so much as to plant these ideas in your head, which is like, what you're working on is important, but why you do it is even more important. Like, I don't know about you, but I go to lots of tech talks, and people spell out for you all of the tools that they used and all of the things that they accomplished, and you're like, interesting, okay, how do I translate that to my own use case? And I think that when people explain why they do things, it becomes a lot easier for you to extrapolate from that and turn that into actual actionable advice for yourself. So like, I'm gonna try to talk a little bit about high-performing organizations and why they do the things that they do. For example, everyone talks about microservices. I was at an Agile Day in the Twin Cities last Friday where someone came to me and said, so our VP insists that we start having some microservices. Why? And is there a downside to this? Like, what should I tell him? And I said, well, I mean, the biggest, of course, it is going to be some work for you to decouple all of the, you know, tightly linked parts of your application. And of course, you know, you have a lot more things to look at when you're troubleshooting, when you're debugging. But something that you'll get from microservices that maybe you didn't have before is the ability to deploy different parts of your application independently. I mean, that is a big win. If you have one piece of your application that really needs to change and another piece that you absolutely can't touch, if they're separate services, that is a win for you. And he was like, okay, yeah, that makes a lot of sense. And so we weren't talking about specific technologies, we were just talking about the why. Also, like on this topic, at Recon a couple of weeks ago, Adrian Cockcroft, who some of you may have just seen speaking upstairs, mentioned that when people complain that if they add a whole bunch of microservices, things will be in like a million Git repos and it'll be much more complicated, they forget that monoliths are actually going to be significantly more complicated because there's complexity there that you have no idea that it's there until you start trying to unpack it, right? Like until you try to decouple all those pieces and until you try to ferret out exactly which services are talking to each other's like session stores, for example, all of that persistent state. And by the way, like when you start talking about microservices and containers, everybody is all excited about 12-factor and statelessness, but like that's sort of a lie, right? I mean, there's state somewhere. Hopefully the state is not in your containers or on your application instances, but there's state somewhere if you have like customers and are making money. Clearly you're storing some kind of information. It's just a question of where you're storing it. And so one of the big pieces that you want to think about when you're making a cloud-native architecture, when you're building out microservices, is to make sure that those services are not dipping into each other's state. Because then, say you want to do independent deployments, but say you have a schema migration, you have changes you have to make. Oh, we can't deploy this one until we've updated the schema for, oh, no, honey child. We don't do that, like separate data stores. So that's like, you know, a little bit of a tangent, but sort of important when you're building out this kind of architecture. So, since we were on the Adrian topic, let's just talk about some of the stuff that Netflix learned. And Adrian's gone over, these are like Adrian points, he's gone over this stuff a million times. I just want to highlight one specific one from here that I think is really useful, which is this idea of simple patterns automated by tooling. Which is to say that tools are important, they are not the be-all and end-all, they are something that you do need, they are important, and high-performing organizations pay attention to not adding complexity that they don't need, but automating the simple, repeatable, sensible patterns that we all want to see in order to achieve the goals that we're all trying to achieve. So, and this is, again, having worked at a small streaming video startup, and I think I was seeing something on Twitter about Adrian actually mentioned Drama Fever in his talk upstairs when he said that we were running Docker in production in 2014, and I had to correct him and be like, actually, we started running it in October 2013. At the point when I'm pretty sure the main thing on the Docker website was like, under no circumstances should you run this in production. And we were like, YOLO, let's run this in production. Why not? What's the worst that could happen? I mean, we weren't actually just YOLOing it into production. We were looking at the fact that LXC was still a fallback, and they were like, hey, let's move to libcontainer/runc. Okay, why not? It's probably fine. Actually, I think runc is fantastic. The OSI is the best thing Docker did in the last year. But anyway, simple patterns, automated by tooling. And you're like, you're talking about Docker, what? Let's talk about platforms. So Netflix has been building a really great open source platform for some time. And originally, Asgard has since been, their continuous delivery environment has since been supplanted by Spinnaker that they just open sourced this week. Built on Spring Boot, Spring Cloud. Like, this is the open source stuff that they're working on with Pivotal that's very cool. But they built a platform. Let's go back to the why. You don't just build a platform because you're like, platforms, that's a thing. We should get one of those. Our VP says to get a platform. No, that's not why you build platforms, right? They built a platform so that developers could self-service their deployments, all right? Remove those blockers. They built a platform so that they could deploy and operate microservices. Again, like, instead of having everything go back to a central blocking lock, this is kind of like if you have a distributed team and you're on the East Coast, and I mean, I live in Central Time. I gotta tell you, I wake up in California and I'm like, I'm so hungry. Why does nothing open until 8 a.m.? But if you're on the East Coast or if you're in Central Time and you're like, okay, and now we're gonna wait for California to wake up before we can make any decisions. Like, you need to decentralize your teams just as much as you need to decentralize your distributed data stores, or you're gonna have a bad time. Sidebar. If you're wondering about all the sidebars, by the way, I got my computer science degree in the 90s, which means the first language they taught us was Scheme, which is a variant of Lisp. So there's lots of parentheses in there. So just imagine like like all the way down. It's parentheses all the way down. But anyway, so this platform is so that they can continuously deliver software. It's like, again, you're watching Netflix. How do you feel about Netflix having a maintenance window? How do your kids feel about Netflix having a maintenance window? Yeah, no, that's not a thing. Like, it cannot be down. You need to actually be up all the time. If you're ordering an Uber and Uber is like not answering you and there are no cars and you can't actually Uber, everything is sadness. Like, we expect, in this day and age, it's 2015, we expect everything to be available all the time. So if you're going to continuously deliver, you can't have long lags and downtime. And this protecting itself from failure is super important. Again, like, at a certain scale, and even at the small streaming video startup that I worked at, like, people were really excited about their K-dramas. They wanted to see those K-pop stars. Like, they were not accepting of, hopefully a human will look at the blinking lights and at some point fix a problem. Like, you need your services to actually be self-healing to keep your customers happy, because this is what people expect. Netflix was not trying to just build a platform so that they could automate all the things. Like, that's not the why, that's not the goal. The goal is to achieve all of the stuff that we've just been talking about. And if you're going to be cloud native, like, that's the stuff that you need to focus on. And so if you're building such a platform, like, you have to think about constraints, right? So like, if you're a developer and you would really like to just do anything that you like and just YOLO anything out into production, because that's what you want to do, you have to remember that, like, there is a day two. Like, someone has to operate that software. Someone needs to be able to deal with any problems. Maybe you need to be able to deal with any problems that come from operating that software. And that means that the software has to behave in an expected way with reasonable constraints. So let's talk about those constraints. What are the constraints? All right, so if constraints are the contract that allows the platform to keep promises, what are the promises? Well, the promises are things like, if you log in this expected way, your logs will actually show up somewhere, possibly Kibana or whatever software as a service that you want to look at your logs, so that your developers can actually see the logs in real time. So that if the expectation is that if your health checks operate in a certain way, then your application will scale as needed. And if your health checks actually tell the truth, again, they don't just report 200 OK when everything is on fire, then when an instance or of a container or a host is unhealthy, it'll be removed, taken out of the load balancer. Again, this is the sort of thing that you're only going to see if you're actually agreeing with the constraints that you've all agreed, the people who develop and the people who operate the software agree that these are the constraints, okay? So if we all agree, and since I have the mic and no one is disagreeing with me, I'm just going to assume that we all agree that we have a platform. All of us have somewhere that we're operating software. Then you got to think about, what promises can your platform keep? For example, like, if your platform is meant to be, all the time available, then can you do deployments with no downtime? I mean, I hope that you can. And if you can't, then that's something that you're moving towards, as you're moving to a cloud-native architecture. But the goal is to not be down, to always be available. And that's something that you're guaranteeing to your users, to your software developers. Okay, so let's talk about how we accomplish this with Pivotal Cloud Foundry. And again, like, Cloud Foundry is actually open source software. Pivotal Cloud Foundry is the commercial distribution that Pivotal runs. So you can take a look at Cloud Foundry on GitHub. Like, it's all out there for you to take a look at. And then this is the sort of thing that Pivotal can actually help you with a commercial version if that's the sort of thing that's relevant to your interests. All right, so these promises start at the API. Because Cloud Foundry is IaaS agnostic, that means that you can run it on vSphere, on OpenStack, on AWS, on Azure, on any of your clouds that you want to run it on. And Cloud Foundry will actually speak, directly to your infrastructure and provision the infrastructure that you need. And again, you're thinking, oh, but I can build this on AWS. Sure. And if you're in the process, say, of moving from your own data center into AWS, then there's an awful lot of re-implementation and duplication of effort that you need to do in order to use all of the API endpoints and hooks that AWS makes available to you. If you're using something like Pivotal Cloud Foundry on top of whatever your infrastructure is, then you can do all that work once. And makes the migration into cloud a lot easier because your developers will continue to just CF push. And on the platform operations side, you've retargeted where the where your platform is actually operating. So all of these things, assuming your API for your infrastructure is solid and actually does these things, like it works fine on AWS, Azure, works fine on vSphere, OpenStack, like it mostly works. OpenStack's API is a little bit janky sometimes. Sorry, OpenStack, but as long as your cloud provider can do this stuff, then the contract of your platform is that you don't have to worry about provisioning your VMs. You don't have to worry about your infrastructure. You don't have to worry about your storage. The platform is going to take care of this for you. All right. So if we start building up the layers, like on top of your infrastructure, the CPI, the cloud provider interface, Pivotal's automation starts talking to that. All right. Then again, if you spent any time managing distributed systems, you know that there are all of these day 2 problems. Whether it's, hey, you did a deployment once, that's super. Now do it again n times. The same every time. And again, if your deployment is like one step above SSH in a for loop, and there's a person who usually runs it, and then that person's on vacation, like you know how this story ends. It doesn't end in happiness. It ends in downtime. So like, you want a more consistent experience. And the scaling out and in, again, like, depending on your cloud provider, that may be trivial. It may require a great deal of, like say you're in AWS. Okay, now you're going to update your launch config. Oh wait, you have to make sure to set the security group correctly for launch config. Otherwise, you're not going to be launching where you thought you were. I mean, it goes on and on and on. So it's like, depending on how much time you want to spend on that stuff, like Cloud Foundry can take care of a lot of that for you. And then again, the automated remediation of any kind of issues. Like, you have an issue, say an instance is gone, you would just like it to be replaced. You don't want this to page somebody. Like, I spent $19.99 to 3 months ago on call for production infrastructure, and I can assure you, like, no one wants to wake up in the middle of the night to hear about a server. Like, maybe you want to wake up in the middle of the night if your service is broken, but you do not want to wake up in the middle of the night to hear that a server is down, because you're like, why didn't it just replace itself? Okay, so if we have tooling in place for all of this, like release engineering, all the stuff that we used to spend a lot of time and a lot of people hours like doing manually with checklists, because you got to have checklists or whatever. There's manifestos about that, right? And deployment and lifecycle management. All right. So what do we do with this? Like, once we've set all that up to talk to our infrastructure, which is great, now we're going to go to container scheduling. And you're thinking, oh, I was waiting for you to get to containers because those are the topic we all want to talk about. Again, containers, necessary, not sufficient. Like, a container is not going to solve all your problems. Schaefer tweeted a while ago that containers will not fix your broken architecture, which I agree with. I also think containers won't fix your broken culture if people aren't going to talk to each other. But say you have a container scheduler. The Elastic Runtime in Pivotal Cloud Foundry is pretty cool. One of the things that you can do in the Elastic Runtime is bring and run your Docker images. Another thing that you can do is use build packs, much like with Heroku. Like, this is it's very flexible, it's extensible, and again, open source. So this is the sort of thing that, like, you have a lot of latitude to do what it is you want to run in this. And of course we use, there's some console in there, there's some etcd, all that sort of thing. The Logregator is something I want to point out because that's actually pretty interesting, which is to say, everybody who runs a large-scale distributed system, like at any level, has logs, right? You probably have a fire hose of logs. You want them to go somewhere. Possibly you have a preferred SaaS provider that you want to send them to. Maybe you'd rather stand something up yourself, but then that's a horrible pain, so you're not exactly sure what you want to use. So then you defer that decision. Maybe you're just dropping the logs in an S3 bucket. Everything is sadness. The developers are upset because they can't look at the logs in real time. And so like the Logregators from Cloud Foundry, are just kind of like a fire hose that you can point at wherever you want to point them at, which is kind of nice. Using the commercial version of Pivotal Cloud Foundry, we have these thing called tiles. So you can just enable an Elk tile, and you're like, excellent. I did not just spend a bunch of time fighting with the indexes in Elasticsearch. Like, I can just set up Elk with the click of a button. Like, that's kind of nice. Or again, whatever SaaS provider you want to use. Let's see. Another thing that's kind of okay. So I should probably mention Bosh at this point. Bosh is, all right, a little secret about Bosh. If you look at BOSH and then you look at the S, change that into an R. You look at the H, change that into a G. Remember what I was saying before about the Borg paper? Yeah, some ex-Googlers like left Google, decided to come write Bosh and try to replicate the experience that they had with large-scale cluster controlling. So Bosh provisions all your infrastructure and talks to the runtime. It's kind of a really cool layer that handles a lot of the undifferentiated heavy lifting that we've all spent forever building with like configuration management and shell scripts and all of that. In Cloud Foundry, like the kind of functionality that you get once you have your runtime in place is the kind of stuff that you need from a platform. For example, role-based access to resources. Like a lot of you probably, if you've worked at organizations that are larger than a small startup, you probably don't want to give everybody production access. Maybe some developers should have access to push some things to production just for their project. And so having the ability to differentiate that without having to do a lot of like really hacky stuff with IAM or whatever in AWS is kind of nice, especially because again, you can make it consistent between your public and private clouds. Another thing I want to point out here actually is like the idea of day two operations. And this is back to okay, you got it working once, that's cool, it needs to keep working, and when something goes wrong, because something will always go wrong with infrastructure, something will always go wrong with applications, like that's just reality. Even if you don't touch it, even if you're like, it's code freeze time, say you're in retail or ad tech or whatever, and it's holiday, and so everyone's like, let's have a code freeze, because that'll make us safer. But the problem with that is that the world keeps moving around you. Whether it's the fact that, like, say, Amazon appears to have built everything on DynamoDB, so when DynamoDB has a problem, like autoscaling just stops working. Actually, Cloud Foundry's autoscaling kept working because it doesn't use Amazon's built-in autoscaling. But all of those things that are going to happen no matter what you do, having a platform that's already got hooks into the infrastructure to recover from this stuff is super useful. Also, like, we got to go back to the buzzword bingo. Like, if we're going to win buzzword bingo, we have to say microservices as many times as possible. And when you're trying to build out microservices, they obviously are going to have a lot of like relationships and dependencies in terms of even their build process that end up being kind of a pain to manage in a lot of the existing CI/CD systems. So this is kind of my little plug for you should check out Concourse, concourse.ci. Free open source tool developed by engineers at Pivotal that we actually use internally for all of the Cloud Foundry builds. And the reason we use Concourse is because pipelines are first-class citizen. So you know how you try to set up like structured builds inside Jenkins that like you're like, oh, I can only add one post build action, what? And so then you add like a whole giant script full of junk into that post build action, and it ends up being a huge pain. And then you have that build trigger other builds, but you want them to like multiply trigger, but only if, et cetera, et cetera. It's like you can build logic like that into your CI/CD system in Concourse like natively. So Concourse is pretty awesome. You should check that out when you're building this stuff. But back to cloud native. So we built our cloud native infrastructure automation because you've got to talk to your IaaS. Because I mean, raise your hand if you want to do a run instances by hand with the CLI. Like that's not a thing you want to do, right? You want that stuff to be automated. So you got Bosh doing that for you. You got your cloud native runtime platform that you can bring all your containers bring all your containers and we'll run them. Like, you don't want to think about this. Again, like there's a lot of, I think people get really excited about all the tools in the container orchestration and scheduling space, but then you get back to reality and you remember that you're here because you want to run applications. You're building software, and if you're not in the business of building platforms, building a platform for most of your, using most of your engineering effort just to keep your platform built and running might not be the best use of your time. Okay, then you're getting into 12-factor. Ooh, excellent, 12-factor, more buzzwords. So if you're gonna be running your your cloud-native applications, you wanna be building them for the cloud. Again, I mentioned Netflix earlier. The Netflix open source tool suite they've open sourced a great deal of really awesome stuff, including Spinnaker that you should check out, came out this week. But this is also where a lot of the value that Pivotal brings that people might not even realize, that Spring Boot and Spring Cloud, a great deal of the development is happening inside Pivotal. And Spring is how you write your cloud native Java, right? So like, realistically, like, even though all of us might be like, hey, we want to write Go microservices because that's fun, but like, realistically, in large enterprises, we're writing a lot of Java, we're writing a lot of .NET. Like, there's Java and .NET have first-class native support in Cloud Foundry. You can bring your Go, you can bring your PHP, you can bring all the other, your Ruby, all the other stuff that you want to run, but this stuff has like first-class support in Cloud Foundry. And the Spring stuff specifically, like, it's a framework that makes it super easy to build cloud-native microservices, build and operate them in the cloud. So, like, you get the application framework for free. You write some Java, and you get the application framework, with Spring for free. So this is kind of like the promises that our platform is making. It's like, and I probably should have put that, honestly, from Pivotal, but this amazing haiku, and I probably should have put a slide with it in there, because it's something along the lines of like, I want to run my applications, in the cloud. Here's my app, run it in the cloud. I don't care how. And so, like, if you're at that place where you want to run your applications, you don't want to spend a lot of time building a thing to let you run your applications, then having a platform that can make and keep these promises that your application will run, it will scale, it will be deployable and repeatable, like, it makes life a lot easier. So if we build this structure into the platform, and at this point you're thinking, wait a minute, so like, all these opinions, all this structure is coming from somebody else. What if it's not what I want? Because I have opinions. I'm a software engineer. This is what I do. And it's like, absolutely. A lot of stuff, like, you have dials in there. You can change it to be what you want. And again, open source. Like, seriously, send a pull request, get it accepted, and the platform becomes what you want it to be. But if you don't, and I think it's a really great thing that it is open source and you have that kind of visibility. So you don't want to buy, and this whole like buy versus build, like, realistically, a lot of times you're not even buying the stuff, it's more you're getting it from GitHub. But if you're going to go get something, you don't want to go get something and not know what you're getting, and then be very, very sad when you realize what you got, what you committed to. And like, the nice thing about Cloud Foundry being open source is you don't have to feel fooled by that stuff. Like, go look at it, see if it does what you want. If it does what you want, and it does what a lot of people want, hey, that's pretty great. You can use it. And I think it's important to remember that this stuff, like all the problems that we're trying to solve, most of us don't have super differentiated, unique infrastructure problems. We have reasonably simple patterns. We want to run apps in production. We want to have them scale. We want to have them perform. We want to have them, have health checks, be able to remediate problems. These are the same problems that a lot of high-performing organizations have had over time and have written and open sourced a lot of tooling to help us with. So it's like we can all benefit from the work that's already been done and not spend a lot of time, developing something that we don't need to. We can spend time developing something that differentiates our organization. So simple patterns, automated by tooling. This is what you get when you go cloud native, because even though cloud native is relatively new, it's also a space that people have already put a lot of effort into, which is great for those of us who want to jump right into it. It's like, if you want your organization to move quickly at the scale that you're trying to operate to run your business, having these advantages, like, right off the bat, makes life so much easier. if you think about Conway's Law, like this idea that people focus a lot on the design of your organization is going to, dictate what your software looks like. But I think the most important word in here is communication. Like if your organization's communication structure is such that you have good communication between the teams who are building and operating things, you're going to get ahead. You're going to win. This is why I really think that when you're thinking about 12-factor apps, you need to complete that handshake by having your platform operations also pay attention to and respect all of the things that the developers are implicitly expecting. So like, if the developers believe that if they write their application in this certain way, it will operate in this certain way, like as platform operators, we have the responsibility to make sure that actually happens. And if we want developers to do the right thing, making the right thing the easy thing to do is the best way to get that, right? It's like, it becomes so much easier when the platform isn't just kind of a free-for-all, like, drop your code in this Git repo, ... profit. Maybe it'll make it to production someday, ? Who knows? Like, having better transparency, having complete visibility through your entire pipeline, and having a platform that makes it easy for your developers to see and operate everything that you're doing is like the right way to do this, at least in my opinion, and in Pivotal's opinion. And if you want to know like the kind of work that you can get out of a platform, even if people don't write Pivotal a check, like the US government is now using Cloud Foundry for the open source cloud.gov. So things like making it easier for people to get their VA benefits or whatever, when they're developing those applications, every time you're developing an application, you don't want to also figure out how to log, how to monitor, how to scale up, how to do a deployment. Like that's the sort of thing that's the undifferentiated heavy lifting that you don't want everyone who develops an application at your organization to redesign again and again and again and again and again. And that's why cloud.gov, running on open source Cloud Foundry, has decided that if they're going to be shipping applications again and again and again, they may as well build a shipyard, build an environment that makes that easy, because you know it's something you're going to do again and again. I feel like in software, we know this. Like, if we're going to do something more than once, we automate it. And if we're going to deploy software more than once, we need a platform to deploy it on. So, yeah, that's it. That's the talk. I would love to stick around for a bit, talk cloud native. And yeah, I work for Pivotal. Thank you for listening.